Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 4, Lesson 4 on decimals and percentages. Now throughout this unit what we're going to be trying to do is really hammer home the idea that there are different ways of representing the fraction that a part represents of the whole, including, not surprisingly, fractions, but also percents and decimals. And we want to understand sort of the connection between those three ideas, which we're going to be getting to today. And we definitely got to, in previous lessons, at least the connection between fractions and percents. Today we're going to be bringing decimals in a lot more. And we're going to be doing this lesson, at least, without our calculators. The next lesson, and the ones after that in the percent unit, we're bringing out those scientific calculators. But in this one, let's at least get some practice using long division to figure out the correspondence between fractions and decimals. And let's get into it right away in the first exercise. Here we go. All right, finding percent by using a decimal product. Exercise number 1. A class has 36 students in it and 25% of the students wore hats to school. Letter A asks us, what fraction of the students wore hats? Write with a denominator of 100, then reduce to simplest form. All right, you probably don't even need to write this with a denominator of 100 to express it in simplest form, but why don't you go ahead and pause the video now and go ahead and do letter A. All right, well, here we go, right? Now, obviously, as we talked about in the last lesson, when we say 25%, what we really mean is 25 100ths. We can reduce this, though, to its simplest form by dividing both the numerator and the denominator by 25 to get what we should already know, which is 1/4, right? 25% and 1/4 are the same fraction of the whole. Now let's take a look at letter B. How many students wore hats? Show your product. So as we all know, right, once we know the fraction that a part represents of a whole, all we need to do to find the part, in other words, the number of students who wore hats, is to simply take this fraction, multiply it by the total, and that will give us our part. So, in this case, we have 1/4 times 36, and that's simple because that's just 36 divided by 4, which means we have 9. 9 students wore hats. All right. Now, let's try to make some connections with decimals, though. Letter C. What is the decimal version of the fraction from letter A? All right, now this is where I want to do a little bit of long division. Let's turn this fraction into a decimal using long division. Now to do that, we keep in mind, right, that 1/4 is the equivalent of 1 divided by 4. Now in order to do that using long division, right, we're going to maybe rewrite it as 1.0, maybe I'll even 1.00. Divided by 4, I put my decimal point right up there. 4 goes into 1 0 times, and when I subtract off, I get 1 and I drop the 0. 4 goes into 10 2 times. 2 times 4 is 8, obviously subtract, and I get 2. Drop another 0 and I get 20. 4 goes into 25 times, and subtract, and I get a remainder of 0. And that means, right, that my final answer is 0.25. Okay. Now that probably isn't much of a surprise to you, right? And in fact, that's what letter D gets at. Find the product of the decimal in C with the total number of students, 36, all right? So what I now want to do is I want to take this decimal, right, which is exactly the same as that fraction, it's just a different way of representing them, and I want to do exactly the same calculation that I did here, right? So I'm going to take my 36 students, and I'm going to multiply by 0.25. So we're going to get a little bit of work multiplying by decimals here. The longhand way. Here we go. 36 times 25. 5 times 6 is 30. Carry the 3. 5 times 3 is 15. Another 3 gives us 18. Index by putting a 0 down. 2 times 6 is 12. Carry the 1. 2 times 3 is 6, plus another 1 is 7. Add 0. 8 plus 10, or 8 plus 2 is 10. Then I have 7 plus 1 plus 1, which is 9. Remember, because I have 2 decimal places here, I move the decimal place over 2 units, and I get 9.00, but of course, that's just the same as 9, right? Now, the whole idea here is quite simple. You know, 1/4 is the fraction, right, of the kids who wore hats. 1/4 times 36, the total, gives me those 9 students. But I could have also done this in a different way, right, where instead of multiplying by the fraction, I multiply by the decimal. And this should make sense, right? The fraction's 25/100ths, which is the same as 0.25, right? That is literally 25/100ths. So when I multiply the total by sort of, if you will, the decimal version of this percent, I get the part. Exactly as I should, right? When I multiply the total by the fraction, whether that fraction is in fraction form or decimal form makes no difference. When I multiply the total by the fraction that the part represents, I get the size of the part, or 9 kids wearing hats. Right? Very, very easy. So let's keep moving on. Let's keep thinking about this idea. All right? Finding the percentage of a whole can always be done with a decimal product. So let's get a little bit of work with that in exercise number 2. Out of 80 total eggs, 15% of them had cracks. Express 15% as a fraction, then as an equivalent decimal. All right, so this is really quite simple, right? Let's first express 15% as a fraction. Well, that's about as easy as it gets, 15/100ths. But what is this as a decimal? Well, never forget, again, that fractions represent division, specifically division of the numerator by the denominator. So this is just 15 divided by 100, but when we divide by 100, we're just moving the decimal place 2 units to the left, so we get 0.15, right? That is the same as 15%, all right? 15%, which is the same as 15/100ths, which is the same as 0.15. Now, let's take a look at letter B. Find the product of the decimal from B, should say from A, with 80 to find the number of eggs that had cracks. All right, so I want to find the product of the decimal here, right, with 80 to find the total that have cracks. And again, I could do 80 times 15/100ths, but that would get a little bit messy. So let's do 80 times 0.15. All right, so we'll do 80 times 0.15. Right, let's do a little bit of multiplication using decimals. 5 times 0 is 0. 5 times 8 is 40. Do a little index. 1 times 0 is 0. 1 times 8 is 8. Add them all up. We're going to get 0, 0, and 12. We've got 2 decimal places, so 1, 2. And we find that 12 of the eggs had cracks. Now, could we do this by taking the 80 and multiplying by 15/100ths? Absolutely. By the way, that is what we did. We just multiplied by 15/100ths in its decimal form instead of its fraction form. All right? And of course, starting in the next lesson, when we've got our calculators, this is going to be our preferred way of doing it because it's just fast. You know, we can just, 80 times 0.15 equals, and we have 12. But keep in mind, this is no different than what we have done for the last 3 lessons now, where we're taking a total and multiplying it by the fraction, right, that the part represents, 0.15. All right, let's keep moving on. All right, some important fluency practice, exercise number 3. To find each of the following percentages of the whole, state what fraction you could multiply by and what decimal you can multiply by. All right, so in other words, if I'm going to find 23% of a total, so I've got the total number of kids that are going on a field trip, or the total number of eggs that are in a basket, or the total number of apples that are sitting in a store or something, and 23% of them fall into a category. Maybe 23% of all the apples have bruises or something like that, right? Then what do I multiply the total number of apples by? Well, in fraction form, right, if the percent is 23%, I could multiply by 23/100ths. All right? Now, in order to multiply by a decimal, though, I would want the equivalent of 23/100ths. What is the equivalent of 23/100ths? Well, I just moved that decimal point 2 units to the right, 2 units to the left, and I have 0.23. Now watch out, because some students will start to pick up on a pattern here, right? And they'll just say something like, well, I'm just going to put down 0 point and then I'll write down the percent, right? Because the percent was 23%, so 0.023. All right, we're going to want to watch out for that in many, many cases, although it does kind of work sometimes. So for instance, to find 56% of the total, we could multiply by, in fraction form, 56 100ths. And certainly in decimal form, if I move that decimal 2 places to the left, that would be 0.56, right? And again, that sort of pattern of saying, well, the decimal is always 0 point and then the percent works great. But here's where it can get tricky, when we have percents that are in the single digits. So if I'm trying to find 8% of the total, right, I would want to multiply the total by 8 100ths. Now, what's tricky here is you wouldn't want to say that, oh, the decimal would be 0.8, because 0.8 actually would be 80%, not 8%. And of course, that's a big difference, right? I'd much rather have an 80% on a test than an 8% on the test, depending on what test I'm taking. So again, we just think about this as moving that decimal place 2 places to the right, and now it would be 0.08. Right? So if I want to find 8% of a total, I'm going to multiply by 0.08, not 0.8. That would be 0.80, that would be 80%. Similar with 2%, right? To find 2%, I would multiply by 2 100ths, or 0.02. All right. And again, I can't emphasize this enough. Each one of these decimals is simply the equivalent of these fractions, right? So 0.23 is the same as 23 100ths. 0.56 is the same as 56 100ths. 0.08 is the same as 8 100ths, etc. All right? Which one you choose to multiply is kind of up to you. But in higher level math, when we find a percent of a total, it's always by multiplying by a decimal. And a big part of that is because you do end up having the calculator. And it's very, very easy to then multiply by a decimal on your calculator. We'll do that more in the next lesson. Let's keep moving on in this lesson, though. See what else we have in store. Exercise number 4. At a restaurant, the bill for food came out to be $47 before sales tax was included. There was an 8% tax on the food. Letter A asks us to find 8% of the $47 using a product involving a decimal. All right, great. So in the last problem, we actually worked with 8%, but just to emphasize, right, what we're really kind of thinking about here is the fraction 8 100ths. And we could most certainly multiply 47 by 8 100ths, and that would give us how much we're going to pay in tax. But we're working here with decimals today. So this is 0.08, whoops, 0.08, and that's what I want to multiply the 47 by. Let me just move this away. I'm going to multiply 47 by 0.08. All right, here we go. 8 times 7 is 56, carry the 5. 8 times 4 is 32, plus another 5 is 37. All right, and that's actually it. That's all I do, because that 0 is not going to contribute anything. I'm going to then move my decimal 2 places to the left, because I have 2 decimals in that product, and we find that 8% of $47 is $3.76. Letter B says check to see if your answer to A is reasonable by finding 10% of the $47 by dividing by 10. Now, this is something that hopefully you learned in Math 7, or Math 6, sorry about that, is that you can actually find 10% of anything by just dividing that thing by 10. It's really cool, and of course the reason why is that 10% of a number, as we saw in the last lesson, is the same as 1/10 of it, right? So if I want to find 1/10 of 47, it's quite easy, right? 1/10 times 47, right? We just move that decimal place 1 unit to the left, is going to be 4.7. Now, if I want to think about this in terms of money, maybe I should write it as 4.70. Now, what do I mean by checking to see if it's reasonable, right? This answer doesn't tell you that this answer is right, okay? But what it does say is that it is a reasonable answer. In other words, if I had made a mistake here and I had multiplied 47 by 0.8, not 0.08, but 0.8, then I wouldn't have gotten 3.76, I would have gotten 37.6. And this calculation would then tell me that that must be wrong, because 10% of something must be more than 8%, right? So if 10% is 4.70, then 8% could never be 37.6. So that 10% rule, where you simply divide the total by 10 to get 10% of it, is actually a really nice thing to check how reasonable answers are, especially if the percent that you're working with is around 10%. 8%, 9%, 11%, 12%, around there, that 10% rule can be extremely helpful in seeing how reasonable your answers are. Anyhow, let's keep going on and let's do one last problem to make sure that we have this idea. Exercise number 5. In a gym class, 75 students took a fitness test. Letter A tells us that 16% of the students received the highest mark on the test. How many received the highest mark? Find your answer using a product. All right, here we go again. So the first thing I want to do is I want to think about 16 divided by 100, or 16 100ths. That's the same as 0.16. Right? So that's easy, right? 16% and 0.16 are the same idea. Now, if I want to find 16% of 75, I'm going to simply take the 75 and multiply it by 0.16. So here we go, 75 times 0.16. 6 times 5 is 30, carry the 3. 6 times 7, 42, plus another 3 is 45, 0. Now it's going to be easy, 75, move this out of the way, add 0 and 0 is 0, 5 and 5 is 10, carry the 1, and then we get 12. Move that decimal place 2 units to the left, and we find that 12 total students received the highest mark on the test. Easy. Let's take a look at letter B. 40% of the students could do more than 3 pull-ups. How many students could do more than 3 pull-ups? Find your answer using a product. Well, why don't you pause the video now and see if you can figure out how many students could do more than 3 pull-ups. All right, well again, 40% is no different than 40 100ths. And as a decimal, that's 0.40. Now, as a little side before we do the product, 0.40 is the same as 0.4. Whichever one you prefer to use is fine, but you might want to stick with this one because it just kind of looks nicer given that it's 40% and 0.40. Now, I want to do that. I want to do 0.40 times 75. All right, so here we go. 0.40 times 75. Of course, 0 times 75 is 0. All right, then 4 times 5 is 20, carry the 2, 4 times 7, 28, plus another 2 is 30. All right, when we add everything up, we get a bunch of zeros with a 3, move 2 decimal places, and we find that 30 of those 75 students were able to do more than 3 pull-ups. I would not have been included in those. Anyhow, so that's it. Simple. We find the percent of a whole by taking the percent, turning it into a decimal, and then just using our decimal product rules in order to find the part, okay? And again, in future lessons, we're going to speed this up considerably because we're not going to be doing any of this. We're just going to be doing that actual product on the calculator. Let's wrap up this lesson now. All right, so today, hopefully, you got a sense for how easy it is to take a percent and change it into a fraction in decimal form, right? And of course, that's very easy because since percents are always a number divided by 100, it's easy enough to just sort of move the decimal point 2 places to the left in order to figure out what decimal the percent represents, all right? Then we simply take that decimal, multiply it by the whole to get the part. Easy enough, and we'll get a lot more work with that idea in future lessons. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.